Okay, so last year you all loved watching me die. Heroically, I gotta say, in the name of science and exploration on every single planet in the solar system. So this year, the What If team is cranking up the stakes and sending me to die even more epically, more epicuriously, more explosively in some of the absolute worst places in the universe. We're doing it big. Supernovas and black holes and entire galactic clusters reaching over 160 million Kevins. That's a lot of Kevins.
Galactic clusters can reach 160 million Kelvin, not Kevin. There are no Kevins in space.
That's what I meant! We're bringing the heat, the Kelvins, for the Kevins! Look, I don't really want to see how these things are going to bring around the chase end times, but, well, Peter said it was in my contract, which I really gotta renegotiate. Ugh. Anyways, in the meantime, get ready to see what it's like to die in the most terrifying things in the universe, starting with something close to home that we all know and love. The sun! You guys asked for it, I'm doing it, baby!
The sun is terrifying, and dying on the surface of the sun would be horrifying.
Ooh, okay, sell me on it, Peter. We're doing epic this year.
Okay, picture this. You're used to seeing the sun from a distance of 150 million kilometers away. That's 93 million miles. But even then, you can't stare at it for more than a second without wearing these cardboard glasses that we bought for the eclipse. Okay, now get as close as human tech has ever been to the sun. Yeah, this is the Parker Solar Probe, and in 2024, it dipped into the edge of the sun's corona, just 6.1 million kilometers above the surface of the sun.
Oh.
And suddenly, you see the sun for what it really is, a G-type main sequence star. In other words, a galactic inferno over 1.4 million kilometers across, filling your entire range of vision with nothing but stellar plasma.
Yeah, that does sound kind of terrifying when you say it like that. Want to zip down there?
There's no zipping down to the surface of the sun. First off, the sun's corona is way too hot to fly through. It's 2 million degrees Celsius. That's 3.6 million degrees Fahrenheit. Now, why is the corona hotter than the surface of the sun? That's one of the great mysteries of the solar system that scientists are still working to unlock. Also, all that radiation and solar wind would fry your ship on the way down. And you'd have to slow down your spaceship to the perfect mathematical degree to actually land. Otherwise, you'd be caught in its orbit and never be able to get out. And finally, it doesn't actually have a surface. The closest thing, the photosphere, is plasma. It'd be like landing on lava soup. So we'll have to teleport you directly to the surface.
Oh, like one of those survive for 5-second dealios? Yeah, I think that'll be a breeze. Rico, beam me down.
Well, I don't know if you're gonna last 5 seconds, Chase. Let's just say we're gonna have to do this in slow motion. You see, the surface of the sun isn't as hot as its corona, but it's still 5,500 degrees Celsius, 10,000 degrees Fahrenheit. The very instant that you teleport to the sun, well, it's so bright that you'd be blinded. Actually, it's so bright that we had to get our video editor to drop the video levels. Otherwise, the screen would be pure white. You'd immediately feel the sun's mass, the power of its immense gravity straining at your muscles and at your very skeleton. It's 28 times stronger than Earth's gravity. Your spacesuit would protect you from the sun's rays, but only for a few milliseconds. Within 0.1 milliseconds, your suit would char. The plastic would begin to warp and your visor would melt. Then your skin would start to melt. Everything would start to melt. It's hot enough on the surface of the sun to melt diamonds. Actually, it's hot enough to boil diamonds. After half a millisecond, your suit would be compromised and boiling plasma would hit your body like a shockwave. It would happen so fast that you wouldn't even have a chance to feel it. Your body would cook, suffering complete organ failure before you could even register that there's a problem. Within 10 milliseconds, your flesh and bones and hair and muscle are turned into gas and plasma, burnt through completely. What would seem like a single flash of light? No, you're gone, incinerated. You've become one with the sun.
Now that's metal. Get it? Like metal. Iron in my body.
Affirmative.
Rico, maybe I should have said, now that's heavy, right? Can we get a take of that? Now that... God, you know, the moment's past. Forget it. Speaking of heavy, check out this black hole. Damn. Ooh, Peter, is there anything about a black hole that isn't terrifying?
Nope. Black holes suck. Suck in everything in their vicinity, that is. There's some astronomical comedy gold for you.
Okay, good one, Peter. Now look, last time I was around one of these black holes, things got a little, string theory alternate dimension pasta crazy.
I'm not sure if you're referring to the wormhole alternate dimension ideas or the concept of spaghettification.
I just know I didn't like it. And I still don't like it.
Well, for good reason. Getting too close to a black hole is a death sentence. You're in orbit around the stellar mass black hole known as Gaia BH1, the nearest black hole to Earth. But don't worry, it's still roughly 1,500 light years away. So if light were able to escape a black hole, it'd be well into the 36th century before we saw it. But trust me, nothing's escaping that monster down there.
Oh, so is that like the huge black hole at the center of the Milky Way galaxy?
No, that would be the supermassive black hole Sagittarius A star.
Whoa, hold on. You're telling me there's more than one black hole per galaxy?
Yeah. Scientists think that there's a supermassive black hole at the center of most galaxies, but it doesn't mean that there aren't smaller black holes around. Gaia BH1 is a stellar mass black hole, much smaller than a supermassive black hole, and it shares its orbit with a star similar to the Sun. Stellar mass black holes are the remnants of massive stars that have burnt through all their hydrogen and helium and imploded. These are the living tombstones of giants. Gaia BH1, for example, has a mass about 10 times that of our Sun, and dying in this black hole would be brutal.
Oh, cool. So naturally you thought, let's just send Chase to Gaia BH1. Yeah, great. Thank you very much, Peter. Cool. Cruel.
Warning. Ship is approaching accretion disk.
What? No! Deaccrete! Oh, zap the VRAM! Rico, flush the cache! Run avoidance! Oh gosh! No, not into the accretion disk!
A black hole is a well of gravity that sucks everything nearby into it. But before that, all that matter and gas wind up in a disk swirling around the black hole.
This is taking a little longer than I thought it would.
The real killer here is the black hole itself. Once you cross a certain distance to the black hole's center, known as its Schwarzschild radius, you are in serious trouble.
Okay, well, if we're gonna do this thing, let's do this thing. Let's get our Schwarzschild on. All right, Rico, depression, let me out of here. May the Schwarz be with you.
what happens when you jump into a black hole isn't very pretty. The instant you get too close to the event horizon, things get weird. Your body undergoes spaghettification. You would be squeezed horizontally and stretched vertically. Even though you're a human, well, your body is now turned into a noodle, the piece of spaghetti we're talking about. Your spine, bones, and skull would be stretched and elongated, cracking and shattering, slowly losing their shape. As you fall, time itself would begin to warp. To an outside observer, you'd appear to slow down, frozen at the edge of the event horizon forever. But from your perspective, time wouldn't stop at all. You'd keep falling, feeling the pull grow stronger and stronger until gravity finally tears you apart.
Jeez, now that is heavy. I nailed that one, Rico, right? Oh, let's use that one. Yeah, I am never going back to a black hole, ever! Nothing worse than those suckers. Ooh, what's this?
This is a neutron star. And it's not just any neutron star either. That's RxJ185635-3754.
No way! That's RxJ185635-3754? I love RxJ185635-3754!
That's right. RxJ185635-3754 is the closest neutron star to Earth, roaring at just 200 light years away. It's so heavy that a teaspoon of that neutron star would weigh 1 billion tons. So, even though it's a sphere that's only 20 kilometers wide, it's one of the densest, most dangerous cosmic bodies in the universe.
Almost as dense as somebody else I know. So, how does a guy like me go about dying in a place like this?
Funny you ask. Well, it's actually incredibly easy to die anywhere near a neutron star. They're weird objects, primarily composed of neutrons, hence the name. The pressure here is so intense that atoms are crushed together. Protons merge with electrons, forming neutrons. The surface of a neutron star is just pure neutrons, 10 billion times stronger than steel. If you got too close, the electronics on your ship and even your suit would short out due to the pulverizing strength of its magnetic field. Within milliseconds, X-rays and gamma rays would destroy you at a cellular level before you could even react. Within 1/10 of a second, the radiation would boil your skin and blood, and then that gravity. Not unlike a black hole, a neutron star would spaghettify you. Your ship and your body would be stretched to their breaking point, and then stretch further and further until every cell and every atom in your body was spaghettified. You were a person, and then you were miles of silly string, vanishing into the neutron star. Horrifying.
Okay, can we go somewhere where I don't get spaghettified? I want to cut down on gluten. Okay, well I don't. I like bread way too much, and danishes, and croissants. I just want to go somewhere where we're not I don't know, linguinified. Come on, let's pick somewhere fun, right? Come on, Peter, where are we going next?
Someplace absolutely petrifying.
Gah! You did not hear me properly.
Billions of light years from Earth, a place beyond terror, El Gordo.
Did you say El Gordo? That's where we're headed? El Gordo?
Affirmative. He said El Gordo.
Okay. El Gordo? It sounds like a luchador. No. It sounds like the guy who makes sandwiches for a luchador. No. It sounds like the guy who, sews up the tights of a retired wrestler who makes sandwiches for a luchador. El Gordo? Peter, come on! We're supposed to be doing epic! This is, pretty... How's El Gordo supposed to wipe me off the face of the universe if it can't even make a sandwich, man? Oh my god!
Well, El Gordo is a cosmic furnace born from the collision of two galaxy clusters. It's one of the hottest environments in the known universe.
It's real big. Is that one galaxy smashing into another galaxy?
Correction. It is a galaxy cluster smashing into another.
Exactly. El Gordo is hundreds, it's thousands of galaxies in the midst of an intergalactic smash-up derby. It's hard to put into words just how violent this process is, but to bring it back to that all-important question,
what would dying be like in El Gordo?
It would be explosive and hot. Imagine you're drifting along in space, riffing about luchadors and sandwiches, and your ship suddenly clocks a higher radiation count. And you realize you're flying into one of the hottest galaxy clusters known to science. Your ship registers a temperature of 160 million Kelvin.
That's too many Kevins.
And knowing you can't understand Kelvin, your computer translates it to Celsius and Fahrenheit. But those millions of degrees barely seem real, and you know that things are about to get way too hot. At that point, you cross into El Gordo, and you hit a local shock front, a cosmic shockwave traveling at thousands of kilometers per second. Your ship would be shattered like the worst car crash in history. You would be thrown clear of your ship into outer space. Your body would be bathed in radiation and struck by hot gas, hotter than the surface of stars. And then, the heat. The wall of pure heat strikes, and you would start to boil, vaporize, even ionize in an instant.
Okay, clearly never make fun of anyone or anything named Gord or Gordo. Or G-Rip, definitely not Kevin. Got it. Something's off, man. I've got the willies. Something behind me? I feel like something's looming behind me. Is there anything looming, Peter?
There's something happening. Soon. Not behind you, but right in front of you.
Oh.
You just went back in time 3.5 billion years, which means you're just in time to witness a supernova. This specific supernova is SN 2016 APS. It's not any supernova, it's the brightest and most energetic supernova we've ever observed. Scientists think it's a rare situation where two massive stars merged before the explosion, making the supernova extra explosive. Boom! Yeah, mega boom. The stars will collapse and then explode. The explosion at its height will be 100 billion times brighter than our sun. That's as bright as our entire Milky Way galaxy. If you're hanging out nearby when it goes off, it's not going to be good news for you. After 1 millisecond, a torrent of neutrinos would flood through your body, heating and rupturing your cells. After 5 milliseconds, the shock wave would slam into you at thousands of kilometers per second, shredding your body before your senses and your pain receptors can even register. After 10 milliseconds, you'd be gone, your atoms carried away in the scorching ball of plasma. So, that's what it would be like to die in some of the most terrifying things in the universe. where should we send Chase to explore next? Venus? Venus is particularly good at making things die, but that's a story for another What If.